Today we'll be going with another topic, routing protocols. So before we start routing protocols, we need to understand why we require something called as routing protocols. Okay. So what is the requirement? Why we need routing protocols? Why we need routing protocols?
If there is condition in the one part of the transmission, the router should have the capability to send it to the other part. So which part it has?
Okay, it's not just about having condition in the network, but for example, when we are moving from source to destination, we may be having several paths available between us. Okay, source to destination, it's not always possible to have single path available, but we may be having several paths. So choices are there, and we need to select best choice among them. Okay, so how exactly we are trying to select the best path out of all the available paths? That is the question. Okay, so these routing protocols, we have two types: unicast routing protocols, multicast routing protocols. Then we go with unicast routing protocols. It is like when we want to send from one source to one destination, then these routing protocols will come into picture. Whenever we are interested in sending from one single node to a group of nodes, then multicast routing protocols will come into picture. Okay. So initially we will look into unicast routing protocols, then we will move our discussion to multicast routing protocols. Okay. So we'll be going ahead with these things. First, we will try to understand what is autonomous system. Okay, what is the concept of autonomous system? Then we will look into one of the unicast routing protocol, that is distance vector routing. Okay, in laboratory also we have discussed these things, right? Distance vector routing. Based on that one, we have something called as RAP, routing information protocol. Then we have something based on link state routing. Okay, this is basically coming with the help of Dijkstra algorithm. Okay, that we will be looking. Based on that, we have something called as OSPF. Then we will see a routing protocol which works between two different autonomous systems. Okay, that is BGP, Border Gateway Protocol. Okay, then these are the contents we have. The question is, like, based on what we will be deciding what is the best path. What factors we will be considering while we want to finalize what is the best path? Hmm? What are the things we may be interested in? Okay, somebody wants to go with round trip time. Okay, then anything else? Yes, shortest path. Okay, then somebody wants to go with shortest path. Then anything else? Channel capacity, or let us say bandwidth, or throughput, let us say. Okay, sometimes we may be interested in reliability also. Okay, so these are some of the parameters which we may be interested in when we are trying to look from source to destination. Okay, so some application it may be asking for delay. It needs minimum delay. Some applications they expect to have maximum bandwidth. Some applications they expect to have shortest path. Okay, so depending on each and every metric, we are going to have different algorithms. Okay, so these are all the things which we are considering as cost. Cost, or we can also consider as metric. Okay. So that is about cost or metric. So when we say what is the cost involved in moving from source to destination, we might be talking about any of those parameters. Okay, whatever the four parameters we have looked into, they are not the only thing, but they are just examples. Okay, we may be talking about distance, we may be talking about delay, we may be talking about throughput, reliability, security, different parameters we may be considering. Okay, then we have something called a static versus dynamic routing theory. So what is the big deal about these things, static versus dynamic routing theory?
in dynamic it changes.
Okay, static means basically static routing tables. The path from source to destination it is going to be fixed. Okay. Dynamic means it keeps on changing. So which one we want to go with? Whether we want to go with static or dynamic?
Dynamic.
Why we want to go with dynamic?
We have options.
We have. So basically what happens is whenever we are talking about these routing protocols or the network, we cannot guarantee like the network will be stable. We cannot guarantee like all the time whatever the links we are choosing or whatever the systems or the routers we are selecting, they will be as it is without any issue. We cannot guarantee that. Okay. So suddenly an intermediate router can go down, suddenly a particular link can get crashed, or the particular link can become congested. Okay, in such cases we will have to choose alternate paths. So if I go with static routing table, then we don't have any other option. But in the case of dynamic routing table, things will keep on changing depending on how network is changing. Okay, and when we go with static routing table, it will be like manually people are going to enter this routing table. Like we have seen in our lab, right? We have deleted manually a particular entry, we have added an entry, and when we see that routing table information also, at the last column, it had like static, right? Because we have manually entered that particular information. Okay. So when the network is very big, even entering the details manually, it will be very difficult. But in the case of dynamic, automatically they will get updated. Okay, that is the advantage we are going to have. Then what is routing protocol? Routing protocol is something like set of rules which we are having to exchange information from source to destination with respect to routing. Okay, with respect to movement of the packets. So the first one, like we have something called as inter and intra-domain routing protocol. So you can just consider the word as a normal English word itself. When we say international, what does it mean? In between different nations. Or when we say international, it includes different countries, right? When we say intra-nation, within the nation or within the country. Similarly, here also, when we consider inter-domain routing protocols, we are talking about routing protocols which exist between two different domains. Domain in the sense an area or an autonomous system we are considering here. Okay. So when we consider two different autonomous systems, and if we have a routing protocol working between these two, that is considered to be inter-domain routing protocol. Or we also have another name for that one, which is exterior routing protocol. Okay. And another one, intra-domain routing protocol, that is within the domain when we want to communicate, then intra-domain routing protocols will come into picture. Okay. And here intra-domain, we can say like interior routing protocols. Okay. So we have something called as optimality principle. Okay. So when we look at the word optimum, what do we understand? We can say like that is the best option which we have. Okay. So when we consider this is the subnet we have, okay, and we want to do like let us say I want to start from B and I want to travel all the nodes which are there in that particular graph. Okay. So obviously I do not want to have closed loops because I don't want to visit a particular node which I have already visited. Okay. So for example, if I want to go to L, I can take this particular path. We are not saying that we are touching all the nodes at the same time, but we are saying that if I have to go here to L, what is the best path I can select? If I have to go with D, what is the best path I need to select? Okay. So the first one represents a graph or a subnet, and this one represents, second one represents a tree which represent the shortest path from a particular node B to all the other nodes. Okay. This is just an example. So we are looking for shortest path routing. Okay. We will also consider the same thing when we discuss OSPF also. So see here what is happening. This is the network which we have. Everybody you are able to see, right? Last. So we want to travel all the way from A to H. This is one of the important question. Okay. So you can see here we have been given with cost. Okay, I am not saying the cost means whether it is reliability or the delay. What it is, I am not saying. Okay, I am just saying if I have to move from A to B, the cost involved is 2 units. Okay, the units can be shortest distance, the units can be delay, the units can be throughput, the units can be reliability, it can be anything. Okay, it can be proportional to anything. So basically from A to B, if I consider the cost is 2. Similarly, I have for all the other nodes, like each edge, what is the cost involved, we have. So how are we initializing? You can just see here. How are we initializing? If we consider this one, you can see all the direct nodes, whatever we have from A, that we have initialized with what is the cost involved in traveling from A to the corresponding nodes. And for the remaining nodes, if you see, we are not giving any information about what is the cost or from where we are coming. Okay. For example, if I consider C, I am traveling from A to C, but I am not saying whether I am coming from B or whether I am coming from E or G or F. From which node I am coming, I am not giving the details. I am just telling, like, I have no information about that particular path. Okay, this is just initialization stage. Okay, you can also consider, like, initially we are considering the cost as infinite. Okay, but the nodes, like if I consider B, if I consider G, these two things I have directly connected, right? I have a direct connection from A to B, I have a direct connection from A to G. So what I am doing, I am updating B, I am updating G. And within the brackets, what I am writing, what is the cost involved in traveling from A to B, what is the cost involved in traveling from A to G. And you can see here, beside B, we have written 2 comma A. It indicates if I have to move from A to B, the cost is 2, and after that we have a letter A, which indicates I have a direct connection from A. Okay, so it actually tells what is the previous node. Okay, whenever I am moving from A to B, what is the previous node? Previous node is A. That means I have a direct connection from A to B. And the cost we are updating. Here also we have updated. And you also observe a notation here. All the nodes we do not have filled in circuits. Okay, but only for A and B we have completely circled, complete bubbling is done. The reason is for B I don't have any other path which gives me shortest path. Okay, is there any other path which gives shortest path to B from A? We don't have. So we have done with B, that is the reason we have bubbled that particular one. G we have not completed it. Okay, once we complete with G, if it is, this is the shortest path, then we will also bubble this path. And we will also darken that particular line, and we will also bubble this particular circle. But so far we have not done. So what we have done, we have selected a node. We have two nodes. One is B, other one is G. Two nodes are there which are directly connected with A. So out of these two, we have selected a node which is having shortest path from A. Okay. So we have AB, we have AG. AB is having 2, AG is having 6. So which one we are selecting first? AB, because that is the shortest path we have. Okay. So we have selected this particular path. Next, next from B we are updating details. Okay. So from B, if I see, I have a connection to C, I have a connection to E. Okay. So you can see here, for C I have updated information. For E also I have updated information. For C what I have updated information, till B I have the cost as 2. From B to C the cost is 7. So 2 plus 7, that is 9, and I am updating that entry here. And you can see within the parentheses, like we have updated, like we are coming from B. Okay. Similarly for E also we have updated. So we had entries, AB we had, AG we had, after that we are including AC, AE. Okay, again we will be looking which is the shortest path. Okay, So A is the one which is providing a shortest path. After 2 distance, we have 9, we have 4. The cast we have 4, we have 9. And we also have 6. So which one is giving us the shortest path? 4. So we are selecting this one. We are selecting E and we updated F. Okay. Till E the cost is 4. E to F the cost is 2. So 2 plus 4, 6 we have updated for F. Previously A to G we had a cost of 6. Okay. But if I am traveling this path, if I am selecting this path, A to B, B to E, E to G, the cost is 5. So I am not selecting this particular path. A to G I am not selecting, but I am selecting A, B, E, G. Okay, so from which direction we are coming? E. So we have updated that way. Understood? Okay. So even though I have a direct path from A to G, which gives us a cost of 6, we are not selecting that particular path, but we are going with a path A, B, E, G, because the cost of that particular path is 5. Okay, that we have updated. Then what is the next one we will be going with? We have done G also. You can see we have circled, bubbled that one also. Then the next one, like we are looking at cost, right? What is the next least cost we have? We have 6. After that we have 9. So we are going with 6. We are from F. We have one node is H, another node is C. Okay. Till F the cost is 6. F to C the cost is 3. So total will be 9. So already the path which we have here, that is also giving us 9. And this path A, B, E, F, C, that is also giving 9. So we will be keeping the previous values. We are not updating that. And another one to go to H. Okay, to go to H, like if I travel from G, it will be bigger path because the cost is 4. But if I travel from A, B, E, F, H, the cost is 8. So we are choosing this particular path. So like that, we have the shortest path from A to H. Okay. So like that, if a particular source is given and a destination is given, we will have to come up with shortest path route. Okay. Clear how we are coming up with this? Okay. Autonomous systems. Okay. So it is not possible like for the entire world we cannot have single routing protocol which is one. Okay. If that is possible, we would have only one government which is ruling the entire world, right? But it's not possible. Okay. Even within the country also, we have different states, districts, mandals, because coordination will be easy when we have different hierarchy. Similarly, here also, the entire region, whatever the world we have, that will be divided into different regions. And each region, we are naming it as autonomous system. Okay. So what is this autonomous system is? Within that autonomous system, all the nodes are going to follow same set of rules. Okay. Same set of rules with respect to routing. Okay, we are not talking about like everybody is going to use Wi-Fi, everybody is going to use wide network, like that we are not saying. But with respect to routing, everybody is going to follow same thing. Okay, so within Telangana, if we consider, everybody will be talking Telugu, that is their mother tongue. But with respect to what kind of work they do, they may be different. Right? Similarly, within the autonomous system, with respect to routing, we are going to follow same set of rules. So like that, we have this autonomous system, this one another autonomous system, here another autonomous system we have. Okay, so it is something like whenever we want to work within the autonomous system, we will be using one set of routing protocols. Whenever we want to communicate between autonomous systems, we will be having another set of routing protocols. So the same thing is described here. What is autonomous system? Then Ethernet switches, different devices, and we have different type of topology here. This represents point-to-point links, and all these things, whatever we have, they represent normal connections. Okay. Next, we move on to a topic wherein we are discussing, like we said, like we have autonomous systems. Within the autonomous system, we have some set of protocols. In between autonomous system, we have another set of protocols. Okay, so we are looking into that one. So we have something called as routing protocols, which is categorized into two different points or two different types: intra-domain or inter-domain. Or we can call it as this one as interior routing protocol, and this is exterior. Okay, interior routing protocols, exterior routing protocols. Within interior routing protocols or intra-domain routing protocols, we have two types. One is distance vector routing and another one is link state routing. Okay, and under inter-domain we have path vector routing. So DVR, LSR, PVR. Okay, these are the variations we have. So based on distance vector routing, we have something called as routing information protocol. Based on link state routing, we have OSPF, open shortest path first, and based on path vector routing, we have BGP, border gateway protocol. Okay, clear? So basically, this distance vector routing algorithm, it works on Bellman-Ford algorithm. Okay, so this one we are just describing Bellman-Ford algorithm. So we have a graph, something like this, and we want to have as per this Bellman-Ford algorithm. If I consider A as starting node, what is the routing table we have, or what are the shortest paths? Okay, here when we consider the path, like if I have to move from A to D or A to E or A to B, we may not be talking about shortest path itself. Okay, we may be talking about any other cost. Okay, so basically this represents the cost, some unit when we want to travel from A to B. Code algorithm, what does it do is, whenever we consider two nodes like I and J, let us say I have n alternative paths are available between I and J. Okay, I can travel from I to 1, 1 to J. I can go from I to 2, 2 to J, I to 3, 3 to J, I to n, n to J. Like that, I can have n alternative paths from I to J. Here, the cost involved from I to 1, we are representing as CI1, and cost involved between I and n is CIN. 1 to j we are considering as D1j. Okay, that is the cost we have on each of these. And whenever I want to find the cost involved from I to j, it will be like the cost involved from I to 1 plus 1 to j, or I to 2, 2 to j, or I to n, n to j. Okay, all the available paths we will have to find out what is the total cost. Okay, after finding this, what we will do is we will select the one which is giving minimum cost. Okay, so that is what we are going to consider here. Okay, in Bellman-Ford algorithm, what we are doing is we are trying to find for all the available paths what is the cost involved, total cost, and we are looking at which one is providing us minimum. Okay, so that is the working principle of Bellman-Ford algorithm. Okay, then we are moving our discussion into distance vector routing. Based on Bellman-Ford, we are coming up with distance vector routing. That is what we said, right? Okay, so when I consider the routing table of A, if I want to move from A to A, is there any cost? There is no cost. Okay, so we are keeping the value as 0. So what are the entries we have? What is the node to which we want to go? What is the cost involved in that one? And what is the next hop? Okay, next hop means if I have to move from this particular node, whatever the node we are talking about, to the corresponding destination. Destination is B, C, D, E. If I want to move from A to B, what is the next one? If I want to move from A to C, what is the next one? Okay, so it is something like you are traveling, let us say from Hyderabad to Delhi. through train. There will be different intermediate railway stations, right, where it will be stopping. So we are talking about what is the next stop. From Hyderabad, when we start, what is the next stop? Okay, so that is what we are talking about here. Because we need to give this information, unless we give this information, we won't be able to select correct path. Okay. For example, you want to go from here to admin block. First, you need to get down from here, right? Okay. So here we have two paths. One is you can use the stairs, or you can go through lift. So we need to say whether you are traveling through lift or on the stairs you are going. Okay. Depending on that, we will be having. So here also we are talking about what is the next stop which we are selecting. So when we consider A to B, what is the cost we have? 5. That is what we have. Is there any other path? Like I can also go in this direction, right? A, C, B also I can go, but the cost is 6. I can also go like this. The cost will be 9. Okay. So I have a cost which is giving 5, 6, 9. Out of all these things, 5 is the one which is giving us less cost, so we are going with that option. Okay. Similarly, we will be going with next one. Like C, I have a direct path. I have to go to D, I have a direct path. Next, if I consider E, the path is there which is giving us 6, and this path is there which is giving us 8. So out of these two, I have to select the one which will give me less cost. So I will be selecting the path through C, not through B. Okay. So that is the reason we are saying if I am going to E, the cost is 6 and the next hop is C. Okay. Clear, right? Like that we have for all the other nodes. That is how distance vector routing works. Okay. So this is the final table we have. Final table means at the end, when we run this distance vector routing algorithm, this is the result we got. Okay, but how we come up with this one? Like how A has come to know about E, or when we consider D is just connected with A only, right? It has no information about other details. So how did it learn about these things? That is a question. Okay, so about these things we will see in next class. Okay, so we will see like how the neighbors are learning about what information you have, how they are exchanging. Okay, let us say I got some information. Let us say C is there. It got some information from A and how to reach B. It also got direct information. It also got from E. When I got information from A, when I got information from E and B about the node B, which one we are going to select? Okay, so that we will see. Okay, in case the distance is same, what we are going to do? In case the distance, like this is something like how we are going to update the entries. Whenever we receive some information, how we are going to update the entries. If I don't know about that path, what I am doing? If I know and the value is less, what we are going to do? Okay, there are some cases where previously I had traveled from A to E through C. C was telling that the cost is 6, but now C is telling that the cost is 8. Okay, same C. Previously it was telling the cost is 6, but now it is telling that the cost is 8. So same node we have updated. So what we have to do? Okay. So that is the question. Okay, that we will see next class. Okay. So that is the important thing which we have. So I don't want others to miss that one.